Good morning. Today we are going to discuss speed control on DC shunt motor. So as usual, first we will see the nameplate detail of the DC shunt motor. So it is very much similar to our load test on a single phase induction motor. Okay. So the motor setup, everything is same. But what we are going to do is we are going to adjust the speed of the motor using some techniques. Okay, before that, what are the nameplate details? The power rating of the motor is 3.75 kilowatt or the HP is 5 HP. Okay, the input voltage is 230 volt DC. Then the speed is 1500 RPM. Then rated current is 20 ampere. Then the insulation class and the remaining things you no need to bother. The connection is the shunt connection. You know different type of connections are available in the DC motor. Today we are going to discuss only the shunt motor. Okay. So this is our motor and this is the actual nameplate detail available in the motor. Whenever you go to industry, you can find the same kind of nameplate detail to observe what are the parameter of the corresponding motor. Okay. Then this is our terminal box. From there we have made some wiring setup in our workbench. This is the circuit diagram of the speed control of DC shunt motor. So this is our load setup. So all the terminals from the DC motor, that is the field winding F1 and F2, armature winding terminals A1 and A2. All four terminals are taken from the motor terminal box. Okay. Including that, you have few more things. What are all the new things? We will discuss with the circuit diagram first. Then it will be easy to you. So this is the exact circuit diagram of speed control of DC shunt motor. Okay. So as usual, we need to apply the input DC voltage. Then you have a DPST switch. Whenever you make the switch to close, you will get successfully DC voltage. Okay. But here we are going to use one special device is called 3-point starter. What is the purpose of the starter? The purpose of the starter, whenever you want to start your DC machine, to limit the starting current, and few more protections are available in the starter. That and all we will discuss in the separate video. Now, what are all the terminals available alone you need to focus. Since its name is a 3-point starter, here we have a 3 points. One is the L, another one is the F, another one is the A. What is L? It is a line in which we need to give our input positive supply. Then, what is F? It is a field terminal. From there, we need to connect our field winding. What is our A? A is the armature terminal. From that, we need to connect the armature. Okay? Remaining things and all, we will discuss. Wait for some time. Then, this is my field winding. This is armature winding. Please observe, these two are connected in parallel, or it is shunt with the another one. Therefore, it is called as an DC shunt motor. So, where is the 3-point starter? Here is your 3-point starter. What are the terminals we have observed? We observed 3 terminals. One is L, one is L, then F, then A. Where these 3 terminals? Please observe here. This is our L, this is our F, this is our A. Okay. Then, where is the input terminal? See, these 2 plus and minus, where it is? Here, please observe. This is the positive terminal, this is our negative terminal. Instead of DPST switch, we are going to use the rotary switch to make the system to on. Whenever I make the switch to on, it will give the supply to our system. Okay. Then this is our fuse control. Please observe. Here we have a fuse control. This is for overload protection. Okay. So the fuse rating, we will keep it as a 125% of the rated current. What is the rated current? It is 20 ampere. 125% means how much? 125 percentage of 20 ampere is 20 into 1.25, then you will get a corresponding value. In that rating you need to fix this, fuse rating. Okay, then what are all the other things related to our experiment? Come back here. What is this? Ammeter. What is this? Voltmeter. What is the purpose of these two? First we will see what is the purpose of the ammeter. Using ammeter we are going to measure current through the field winding. We are going to measure current through the field winding, that is your IF. That is your IF. Okay. Then what is the purpose of this voltmeter? Using this voltmeter we are going to measure the voltage across the armature, that is called as VA. I hope these notations are easy to understand. This is voltage across the armature. This is current through the field winding. To measure the current we need to use ammeter. To measure voltage we need to use the voltmeter. What is the difference between this voltmeter and the earlier AC experiment? Please observe this straight line. This indicates these are all moving coil instrument. It is used to measure only the DC quantity. Okay. Then what is this variable resistor? What is this? This is our rheostat. How many terminals are there? 3 terminals. Observe, 2 fixed terminals. Let me make it as a 1 and 2. 1 and 2 are fixed terminals. This one is the variable terminal 3. Similarly, please observe here, fixed terminal 1, fixed terminal 2, variable terminal 3. What is the purpose of this rheostat? Using these rheostats, we are going to adjust the speed of the motor. What are the 2 type of speed control you have studied? One is the field control method. Another one is the armature control method. Okay, so today we are going to do these 2 speed control. First we will discuss what is the field control speed technique, then we will get into the armature control. Before that, what is the circuit diagram? This is our circuit diagram. How to make the actual connections? Already we gave all the connections in the workbench. You will see one by one as per the circuit diagram. So this is plus, minus, it is readily available here. Okay, then DPST switch, it is permanently connected inside. Okay, then fuse, this arrangement also done. Then from where we need to start our experiment? We need to start our experiment from these 2 points. These 2 points. What are all these 2 points? Plus and minus available in this workbench. Plus and minus here. From the plus, from the positive, we need to connect it to the terminal L in the 3-point starter. Please observe, from plus, positive to L. One terminal of our 3-point starter we have connected. Then from F to one terminal, fixed terminal of our field rheostat. Where it is? See here, this is our F terminal. This is our F terminal. From the F terminal, one terminal is connected to the field rheostat. Where is the another terminal? This is our another terminal. We need to connect it to this another terminal. Come back here. This is our another terminal available here. Okay. From here, we need to connect it to the positive terminal of the ammeter. Where it is? See here. Here you have a positive terminal. Okay. Then from the negative terminal of the ammeter, we need to connect it to the F1 terminal of the field coil. So where is the negative terminal? So here you have 2 options for the negative terminal. One is the 1 ampere, another one is the 2 ampere. We are going to use 2 ampere as the negative terminal because the rated field current of our motor is the 2 ampere. The field current rating is 2 ampere. The entire current rating is 20 ampere. Don't get confused with the field current, rated current and the rated current of the motor. Okay. So therefore we are going to take it from the 2 ampere terminal. Then we need to connect it to where? Please observe the diagram. From the negative terminal of the ammeter, we need to connect it to the F1 terminal. Where it is? Here it is available, F1. F1. That's all. So this portion is over. This portion is over. This portion is over. Please don't bother about the F2. We made the connection of L, then F, rheostat, ammeter, then F1. What about the A? Here you have a terminal. Here we have a terminal, okay, from our 3-point starter. From the A, we need to connect it to the one fixed terminal of the next rheostat. See here, here it is. So, take one terminal A to this fixed terminal, A to this fixed terminal. Then, from the variable terminal 3 of the same rheostat, we have to connect it to A1. Where is the variable terminal? Here it is. Here it is. From there, we need to connect it to the A1. We need to connect it to the A1. Then come to circuit diagram. Come to circuit diagram. From the variable terminal to A1 we have connected. What else remaining? What else remaining? We need to finish these two connections. Then we need to connect one voltmeter across our armature. Am I correct? Come here, come here. This is our voltmeter. It has 4 terminals. It has 4 terminals. Don't get confused. Don't get confused. Positive terminal. We have one positive terminal, but we have a 3 negative terminal. Which one we can choose? Again, we need to check the rated voltage of our system. The rated voltage is 230 volt. So which one I can choose? 150 is lesser than the rated voltage, so I can't use this terminal. 150. Here 300. Here 600. So out of this, the 300 is a suitable one. So we are going to connect it to the 300 terminal. Okay. See now the 300 terminal is connected to the negative. See. Here we are going to connect it to the, here we are going to the negative terminal is we are going to connect it with the A2, F2, then negative. Please observe A2, F2, then it goes to negative terminal available in the workbench. That's all. The entire connection setup is over. Entire connection setup is over. Then now we need to start do the experiment. Before that, we need to observe few initial conditions. These two rheostats, as per the circuit diagram and the theory concept, the field rheostat, we need to keep it in the minimum position. Armature rheostat, we need to keep it in the maximum position. Shall we check that one? See here, this is our fixed terminal. This is our variable terminal. So I am going to keep the knob here. So thereby it will offer 0 resistance in the circuit. This is the minimum position. Okay. Then this rheostat should be maximum. Please observe. Our fixed terminal is here. Variable terminal is here. The knob is in the opposite side. The knob is in the opposite side. The entire resistor will get add. Then only it will reach the A1 terminal. Thereby it is in maximum. This is in minimum. That's all. These are all the initial setup we need to ensure before start the machine. How to start the machine? How to start the machine? Very simple. Very simple. After checking all the connection diagram, we need to start the machine using this starter. What is the initial setup? First we need to make this DPST switch to on. Then using this 3-point starter, gradually we need to move this handle to the on position. This is off position of the starter. This is the on position of the starter. We need to make the handle to gradually move from off to on. Then keep the handle in the on position. Then start do the remaining procedures to carry out the experiment. Okay. Now we are going to start the machine. Please observe, after checking all the connections, since it is a speed control, we need to ensure that the motor is in unloaded condition. Please observe, we are not loaded the machine. Okay. Even we can remove the load setup. Please observe, only the motor alone is in a no load condition. We are going to carry out the speed control method under no load condition only. Okay. So now our motor is in no load condition. Now we are going to gradually make the starter to move from off to on. Before that, we need to turn on the DPST switch. So I made the system to on. Then using this 3-point starter, gradually we need to adjust the handle from off position to on position. Then we need to observe the speed of the motor. Now you observe, I am gradually adjusting the handle. We made it into on position. Please observe the motor rotation. Please observe the motor rotation. Your motor getting rotates. Okay. How to measure the speed of the motor? You know very well. We need to use the tachometer. We need to use the tachometer to measure the speed of the motor. How to measure? Using this tachometer, first we need to set it in the RPM setting. This is meter per minute. Change the knob to RPM. Then you need to press this button. Once you observe the rotary message, the meter is ready to measure the speed. Now we need to keep the tachometer in the shaft and we need to measure the speed. What is the speed of the motor now? It is 1280 RPM. What is the rated speed? What is the rated speed? It is 1500. What we are going to do? First we are going to, by adjusting the armature rheostat, we are going to set the rated speed. Then we are going to carry out the field control method. Okay. For that, please move here. Please move here. Here we need to adjust the rheostat. Thereby we need to try to achieve the rated speed of the motor. This action we need to do simultaneously. Any one of the person need to measure the speed. Then one person need to adjust this rheostat. Thereby we can attain the rated speed. Now we adjusted some position. We will go back and check the rated speed of the motor to achieve the rated speed. How much it is? It is around 1410 RPM. Let me adjust it little more and we will check whether we are getting the rated speed. Now we are going to adjust little more and we are going to check the speed of the motor. Okay. Now you can observe we reached the rated RPM of the motor. Okay. From there we will start do the experiment. The first procedure what we need to do means we need to observe the tabular column. It will give you some information about the procedure what we need to do. What is this procedure we need to do means the very first one we are going to note down the armature voltage. Go there and observe the armature voltage. How much it is? It is around 110. In between the 100 and 110, it is around 105. It is around 105. We need to note down that armature voltage here. Then entire experiment we need to keep this armature voltage as a constant one. Then gradually we need to change the field current value accordingly. what is the change in the speed? We need to tabulate. That's all. Very simple experiment. Set the armature voltage, change the field current and observe the change in the speed. First we will note down the initial reading. What is the current RPM? It is 1500. What is the corresponding field current? Please measure using the field current ammeter. So this is our field current ammeter. This will measure the current through the field winding. Please observe how much it is. 0.3, 0.35, 0.36, 0.35 and 0.36. Okay. So 0.36, 0.36 ampere. That's all. Next we need to note down one more thing. In this ammeter, what is the full scale reading? 1 and 2. If it is 1, we can take the same reading. If it is 2, what we need to do? What is the actual reading? We need to multiply with 2. We will note down that procedure in our tabular column. Here we need to multiply this reading with 2. After taking the readings, you multiply the same and you need to make the first table. Okay. Now, what is the next procedure? We need to change the field rheostat. Now it is in minimum position. We are going to increase the value of the field resistance. Thereby, field current will get decreased and we will observe what is happening to our speed of the motor. Okay. Now we will reduce the field current. How to reduce? By adjusting the field rheostat value. We are going to increase the field resistance. We are going to increase the field resistance and we are going to measure the corresponding change in the field current also. You please observe. Let me vary the field current. Please observe. Please observe the change in the field current. Please observe the change in the field current. Yes, it is getting gradually decreases. Okay. Now initially it was 0.36. Let me keep it in 0.3. Let me keep it in 0.3 exactly. Okay. 0.3. Okay. Now we will note down the field current value here and we will measure the speed of the motor. Come. As per our theory, if you reduce the field current, the speed must be increased. See, now the speed was 1822. The speed is increased from 1500 to how much? Exactly. Let me hold it in this two hand. Yes, it's around 1592 RPM. Yes, now it is exactly 1600. Okay. So 1600 is the increase in speed. Now please note down 1600. Okay. Next what we need to do? Further we need to increase the resistance value. Thereby field current will get decreased and we will measure the speed. We will take one more reading. It is around 0.25 we will take. Okay. Around 0.25. Yes, it's exactly 0.25. So now we further decreased the field current to 0.25. Now come, we will measure the speed. Obviously it must be a increase in value. Please observe. Now it is, how much it is? 1678. Am I correct? Or 76? We will keep it as a 1676 exactly. We will take 1676. In this way we can decrease the field current and we will observe the increase in the speed. This is the one procedure. Then what we need to do? Again we need to bring back our speed to 1500. Then we need to adjust the armature voltage. How we will do that? Please observe here. Please observe here. Again, we need to bring back this field rheostat to minimum. Okay. Then come to the armature voltage. Earlier we keep it as how much? Earlier we keep it as 105 volt. Now what we are going to do? We are going to decrease the voltage. We are going to decrease the voltage to some value. Then we will do the experiment. This in second setup, we will reduce it into, we will reduce the armature voltage. We will reduce the armature voltage to 100. Please observe. 100. Please observe. We reduce the armature voltage into 100. So in the second setup, the VA2 we are going to keep it as 100. Then again we need to measure the speed for the 100 voltage. Then we need to stop, decrease the field current, and we need to take the reading. Let me take one reading. What is available here? As usual, the field current is 0.36 at the initial value. 0.36 at the initial value. What is the corresponding speed? What is the corresponding speed? We will measure the speed. How much it is? Observe. Now it is 1440. 1440 RPM. We will note down the same value here. 1440. Next, what we need to do? Yes, very good. We need to decrease the field current. Then we need to start tabulate the RPM. Let me do one more reading in the same setup. Field current, we will keep it as a 0.30 by adjusting the field rheostat. I am going to adjust this, and we are going to keep it in 0.3 ampere. 0.3 ampere. Then we will measure the corresponding speed. What is the speed here? What is the speed here? It is around 1514 RPM. 1516. Yes, we will take this final value as 1516 RPM. For the same field current, there is a reduce in the speed. What is the theory behind this? We will discuss later. Before that, we have one more method. That is our armature control. What is the procedure for the armature control? It's very simple. In the field control method, we kept armature voltage as a constant. Then we varied the field current. It is vice versa here. Here we are going to keep the field current as a constant. Then we are going to change the armature voltage, and we are going to take the corresponding speed of our motor. What is the initial field current we will keep? We will keep the initial field current as the default value as 0.36 ampere. Okay, into 2 you need to put, don't forget. Okay, 0.36 into 2 we will set in our field current method. What is 0.36 we kept. Then adjust the armature voltage and take the corresponding reading. Okay, in field control method, this field control method is mainly used to attain the speed control from the rated speed to the below value. From the rated speed, what is the rated speed? We need to set it as 1500. Then by doing the speed control technique, we need to reduce the speed from 1500 to some value. But in field current method, by decreasing the field current, we increase the speed from rated RPM to some extent value. Okay, அப்படியே ulta, we need to ulta the procedure from field current to the armature. Here first we will set the rated speed of the motor. First we will set the rated speed.